Okay. This is question 8 from the chapter 6 test in your textbook. Review questions. So in this question, we have 5 siblings: Paula, Mike, Stephanie, Kurt, and Emily. They're randomly seated along one side of a long table. What is the probability that the children are seated with the 3 girls in the middle and in order of age? All right, so when you read this question, you kind of get the sense that it's a counting question, because like we're thinking about the positions in the table, for example, and we're like putting people in those seats. So because it's a counting question, you're going to think about the fundamental equation of probability, which is this. And like I always say, we got to find the number of outcomes of our event. And in this case, like we have one event here, and then we have another event over there. And we need to divide that by the total number of outcomes. And also, like I always say, the total number of outcomes, this is actually going to be easier to calculate because we're just taking 5 people and we are just arranging them in different seats. So for the first one, we can pick any of the 5. And the second one, we can pick 4 people because there's 4 people left over. The third seat, we can pick 3 people. Fourth seat, 2. Fifth seat, 1. So the total number of outcomes is going to be 5 factorial. All right. So looking at A, we want to, actually, give me 1 second. I want to clean this up a little bit. Looking at A, we need the 3 girls in the middle. So I'm going to say that these 3 seats here are for the girls. And also there's 3 girls. There's Paula, there's Stephanie, there's Emily. So the 3 girls can be seated like at any positions here. And if we think that way, then there's 3 possible girls that we can put in the first seat, 2 possible girls for the second seat, and then 1 possible girl for the third seat. So for the girls at least, we're going to have 3 factorial. So here, let me just write the probability over here. So 5 factorial is the total number of outcomes, and then we have 3 factorial. And keep in mind, this is just the number of ways of arranging the girls. That's the 3 factorial. Okay, so we took care of the girls. Now, where can the boys sit? The boys can sit either here or here, so at the ends of the table. For the boys, we have 2 ways of choosing a boy to go here, and then we have 1 way of choosing a boy to go there. So for the boys, we're going to have 2 factorial. Let me just clean this up. So yeah, that's the probability. Then you just calculate this fraction here. This is going to be equal to, if I did this correctly, 2 over 5 times 4, which is 1 over 10. So this is the answer for A. All right. So A is, I would say, pretty straightforward. B is where it gets a little bit more interesting. Okay. So I'm going to reset some of this stuff. All right. Okay. All right, good. So I'm going to reset some of this stuff. And now we're going to look at B, which says, what is the probability that the children are seated in order of age? Okay, so we still have 5 factorial as our denominator here. That has not changed. That has absolutely not changed. What has changed now is how we can order them. Well, I should also mention that like we're going to assume that everyone is aged differently. So everybody has like a different age. We're going to make that assumption. And if we make this assumption, then we need to look at like how we can order them in terms of age. So the oldest can go here. And if the oldest goes here, I'm going to write O for that. The second oldest has to go here. So I'll write like O1 for the oldest and then O2 for the second oldest. And for the third oldest, that person has to go here. The fourth oldest has to go here. And the fifth oldest has to go here. So there's only one way. Or is there? Because instead of having my oldest be on the like left side of the table, I can move my oldest to the right side of the table. That means that my second oldest, that means that my second oldest needs to go right beside my first oldest. And that means that my third oldest stays where they are. My fourth oldest goes here, and then my fifth oldest goes here. So there's not just one way of arranging them. There's actually two ways, with 1 plus 1 over 5 factorial. This is 2 over 120. That'll give us you 1 over 60. Or give you 1 over 60. So that's the probability for B, 1 over 60. And this is only because we're sitting at a table. You can sit on the very left side or the very right side. So there's going to be two different ways to arrange them.